Alright, so we are going to simplify some radical expressions using a little tool, and that is something that you're already familiar with. It's prime factorization. So here we've got some radical expressions, or expressions with radicals. So 7 times the square root of 27 would be one. And we want to get this in its simplest form. And what we can do is actually pull 27 apart and see if there's any perfect squares hiding inside of it that we could square root and put on the outside of the radical. So first, let us just review prime factorization. So let's say I had the number 56. Whoa, number 56. And I wanted to factor it. And I wanted to get it down to all of its prime factors. So I could do a little factor tree, and doesn't really matter, so 56, I could look at that as 8 times 7 and go from there, or I could do 2 times 28 and go from there. Really doesn't matter, I'll end up with the same prime numbers at the end. So I'll do it both ways, actually. Do 8 times 7. Okay, so 7 is a prime number. You can only divide it by itself or 1 and get a whole number. So we're done there, but 8 is not a prime number. It can go farther. So 8 is 2 times 4. 2 is a prime number, so we're done there, but 4 is not because we can break it up into these prime numbers. So 56 is equivalent to 2 times 2 times 2 times 7 is what that's saying. And let me just show you that it would work this way too. 28 times 2. 2 is a prime number, but 28 we can break down into, let's say, 7 times 4. 4 we can break down into 2 times 2. So again, we've got 2 times 2 times 2 times 7. Now, why is that important? Well, for this reason, the product rule of radicals says that, for example, in this case, if we were to look at the square root of 56, the product rule is saying that's equivalent to, for example, the square root of, let's say, 7 times the square root of, we could multiply these together. So 2 times 2 times 2 is 8. So 56 is equivalent to the square root of 7 times square root of 8. 7 times 8 is 56. So we can break up radicals into radical expressions of the factors of the original radicand. So what I just did here was going this way. We had a number that can be expressed as the product of two other numbers. So 56 could be expressed as 7 times 8, and that means we could break it up into square root of 7 times the square root of 8. Now, what we'd actually want to do, that doesn't really get us anywhere, but what we would like to do is like this. What about this? So 7 times 2 is 14. So we could say the square root of 56 is equal to the square root of 14, 7 times 2, times the square root of 4, 2 times 2. And that takes care of all of our, so we're doing these two factors times these two factors. 14 times 4. So the square root of 14 times the square root of 4. And now that gets us somewhere because the square root of 4 is just 2. So this would just be 2 square root of 14. So that'd be a simpler version of the square root of 56. Right? So what we're doing is we're breaking the radicand, the thing under the radical, into its prime factors so that we can uncover perfect squares. For example, 4. 2 times 2 is 4. 2 times 2 is 4. In other words, 2 squared is equal to 4. So 4 is a perfect square. In other words, we could just square root 4, or in other words, square root 2 times 2, and get 2. And we just pull that out and put that on the outside of the radical. So that's what we're doing. So let's look at some examples. So 7 times the square root of 27. So let's first factor 27 to see if we can find any of these perfect squares. And what we do is we break it down into its prime factors, and we look for pairs of numbers. So 2 and 2, right? Because we know we can write that as 2 squared, and then we could just square root 2 squared. So 27 is 9 times 3. 3. 3 is a prime number. 9 is 3 times 3. So 27 is 3 times 3 times 3. So we've got a pair of 3's here. I'm just picking these two, and you could pick this 3 and this 3, whatever. So this is equivalent to 7 times the square root of 3 squared times, and then we had another 3 left over here, times 3. Because 3 times times 3 squared is 27. So the square root of 3 times the square root of 3 squared is equivalent to the square root of 27. Alright, well the square root of 3 squared is just 3. So we've got 7 times 3 times the square root of 3, which is 21 times the square root of 3. Not c, or backwards c, or whatever that was. 21 square root of 3. Alright. Let's try another one. 2 square root of 72. So 72 is, what is that? 9 times 8. 9 we already saw. We can break down into 3 times 3. So 9 is 3 squared. 8, we can do 4 times 2. 4 we can break down in 2. So we've got 2 perfect squares here. Alright, so what we can do is we can say this is equal to, actually let me go back to my nice color, 2 times the square root of 3 squared times the square root of 2 squared, and then we had a 2 left over here times the square root of 2. So this is equal to 2. So the square root of 3 squared is just 3. Square root of 2 squared is just 2. And then we had the square root of 2. So 2 times 3 times 2. 2 times 3 is 6, times 2 is 12. So this, in its simplest form, is 12 times the square root of 2. Alright. You can do this one. That's for you. Let's look at this one though. This is equivalent to 4 times the square root of 50 divided by the square root of 72. Now we can find the prime factors of 50 and 72 and handle each one individually like we did here. So, and I'll just do the factor trees out this way. So 50 is 25 times 2, and 25 is just 5 times 5. So there we go. 25 is a perfect square. We square root it, we get 5. So yeah, so this, well, let's do the bottom here. We got, well, we already did square root of 72. So we know 9 times 8, 3 times 3, And we know 8 breaks down to 4 times 2, and then 2 times 2. So we've got 3 squared, 2 squared, and 2. Okay, so let's see what we can do here. Let me write the whole expression as 4 times. Now the top, we've got this perfect square, 25. It's 5 times 5 is 25. So if you square root, that's 5. And then all we have left is square root of 2. So square root of 50 is 5 times the square root of 2. And then here we've got square root of 3 is 3. Square root of 9 is 3. I meant 3. The square root of 3 squared is 3. Square root of 2 squared is 2. And then we had a 2 left over here. So square root of 2 and square root of 2 cancel out. So we've got 4 times 5 over 3 times 2 is 6. So it's 4. 4 times 5 is 20. So this is 26. And then we could break that down a little bit. Take a 2 out of that. So it'd be 10/3. Which is equal to 3 and 1/3. Yeah, 3 times 3 is 9. Then we have 1 left over. So 3 and a third. Alright, so that was a little bit more complicated, but not too bad. I'll let you do this one. Yeah, good luck.